Hi students, in today's video I am going to discuss about thermochemistry numericals. Before going to numericals, some important data I am going to give: combustion reactions, how easily we can write the products, and next some standard forms also I am going to discuss. See, combustion reactions. First, carbon on combustion. Combustion means who will support? Oxygen. Oxygen support for the combustion reactions. Carbon plus oxygen, it gives rise to CO2. CO2, what is the standard form? Standard form is gaseous state. Oxygen, what is the standard form? Gaseous state. Carbon, what is the standard form? Graphite state is standard form. We have diamond and graphite. Graphite is thermodynamically stable. And in standard form, first let me write here standard form, students. Standard forms. Carbon, G, is nothing but graphite. Graphite is standard form. Next one, oxygen. Oxygen dioxygen, that is gaseous state, not trioxygen. And next one, nitrogen. Nitrogen also available in the form of gas. Standard form is gaseous state. Next, hydrogen, it is in gaseous state. Next, fluorine. Fluorine, it is in gaseous state. Next one, chlorine, Cl2, it is also in gaseous state. Next, bromine, it is in liquid state. Iodine, it is in solid state. Iodine, it is in solid state. Next one, phosphorus, white phosphorus, white form. White phosphorus is standard form. And sulfur, that is orthorhombic. Orthorhombic. Orthorhombic form is standard form. Next one, others also there, that is like magnesium. Next, aluminium, sodium, these are all available in the form of solid. So these are standard forms. Now come back to the combustion reaction. See, carbon combines with oxygen, it gives rise to CO2. It is already in balanced condition. But what is the standard forms also we have to write. Based on this also we have a theory questions. Carbon they will give in diamond state. Oxygen it is they will give in some other state, like other physical state they will change. Which is the standard form of the reactions they will ask question. Okay, now next one. Next one. Methane on combustion. Methane on combustion, it gives rise to CO2 plus water. Make a note, students, all hydrocarbons on combustion gives carbon dioxide and water. Based on that, we have to balance. Methane on combustion. Methane, what is the standard form? It is gaseous state. Oxygen, what is the standard form? Gaseous state. Carbon dioxide, gaseous state. Water, liquid state. So I am covering some theory questions also. These are all theory numericals. So I am covering theory numericals. First make a note, then we will go to the value based numericals. Next one, see, balance this one. For balancing also we have a trick. What is the, students? First we have to balance carbons. Next we have to balance hydrogens. And the last step we have to balance oxygens. We have to balance oxygens. Okay. Now here first carbons how many? Yes, 1, 1. Hydrogens 4 here, but here only 2. 2 2s are 4. Now here 2 plus 2, totally 4 oxygens. Here only 2. Just write 2 oxygens. This is the standard form of methane combustion. Methane combustion. We are always speaking for 1 mole here. 1 mole. That is standard form. Next one. To understand more better, I am giving next one more question. Suppose benzene. Yes, benzene. This is also hydrocarbon. Hydrocarbon is nothing but only carbon and hydrogen. Hydrocarbons on combustion gives, what I said to you, CO2 plus water always. Here also products will not change. But based on carbons and hydrogens we have to balance. Don't take here, don't change first one. What is this? Carbon, methane and ethane or else benzene. Don't change the main one, hydrocarbons. You can change other one. What is that? Oxygen we can change, or else carbon dioxide you can change, H2O you can change. But this we should not change. See here, liquid. Benzene liquid stranded form. This is gaseous state. This is gaseous state. This one liquid state. Okay. Now balance. What I gave here trick students. Carbon. First carbon we have to balance. Next hydrogens. Next oxygen. See how many carbons here? 6. 6 carbons. Right hand side right. Next how many hydrogens? 6. 3 2s are 6. 6 plus 2, 12. 12 plus 3, 15. 15 by 2 you can write. Here you will get fractional value also, there is no problem. But because of getting normal number you are taking here 2 moles, that is wrong. If you will get here fractional value also no problem, but here we have to maintain 1 mole. Okay, now try to do another question students. Ethane. Ethane on combustion. What I said to you? CO2 plus water. Always hydrocarbons on combustion we will get CO2 and water, right? So now try to balance this reaction. CO2 plus water. This is liquid state. This is gaseous state. This is gaseous state. This is gaseous state. Ethane gas. Now balance this reaction. How many carbons? 2. How many hydrogens? 6. How many oxygens? 2 2s are 4. 4 plus 3? 7. 7 by 2. That's it. Okay. Now we are going to discuss some numericals. So first what I have given stranded forms, whatever I had given combustion reactions, please go through this. And the third numerical I will explain one more theoretical numerical I will explain. First value based numericals I am explaining. Listen. Previous year questions I have collected students, NEET and mains. See first one, enthalpy of combustion of methane, graphite is nothing but carbon, and dihydrogen at 298 Kelvin are minus 890.3 kilojoule per mole, minus 393.5 kilojoule per mole, and minus 285.8 kilojoule per mole respectively. Enthalpy of formation of methane they are asking. Combustion informations, 3 indirect informations they had given. They are asking you to calculate formation of methane. First you will have to write combustion reactions. Just now I said no, how easily we can write combustion reactions. Yes, make a note. First one, methane on combustion, right? Methane combustion gives rise to CO2 plus water. So balance this reaction. How to balance? So here carbon, hydrogens 2 2s are 4, 2 plus 2, 4. This is balanced condition. And stranded state. What is the stranded state students? Methane stranded state is gaseous state. Oxygen stranded state, gaseous state. Carbon dioxide, gaseous state. Water, liquid. So what is this value they give here? Delta H, how much they give? Delta H equal to minus 890.3. So always taking this value, it will go for long procedure. For this I will make it into simplified shortcut. Let it be take it as X. Let it be take it as X. Okay. Now equation 1 X. The delta H value we are taking X. Now next one, graphite. What is graphite students? Carbon. Carbon graphite form. Carbon combustion. What we get? C plus O2 gives rise to CO2. It is in gaseous state, right? It is in gaseous state. It's already balanced condition. What is the delta H value they gave? Minus 393.5 kilojoule per mole, right? So let it be take it as Y. Now next one, what is the next one they give? Hydrogen, dihydrogen. Yes, it is available in the form of dihydrogen. H2 combustion, again reacting with oxygen, gives rise to H2O. H2O, what is the stranded form? Liquid state. It is in gaseous state. It is in gaseous state. Is it balanced? No. Hydrogens balanced, but oxygens right hand side is 1, left hand side 2. Then you can make it into half. So don't take 2H2. I said no, standard conditions is nothing but 1 mole. You have to maintain this one 1. So what is the value, students, here? Delta H equal to, what is the value? Minus 285.8 kilojoule they had given. Okay, let it be Z. Okay, now what is the required one? Enthalpy of formation of CH4 they are asking. CH4 is nothing but methane. Methane formation we have to write. Before we have taken combustion reaction, now I am writing formation. What is the formation? Carbon plus H2 gives rise to CH4, right? It is in gaseous state, right? Is it balanced condition? No, it's not balanced condition, right? So what is this? This is graphite state. G I am writing. Hydrogen gaseous state, standard form. This delta H, how much they are asking? How much they are asking? Now look into this. How many hydrogens here? 2. Here 4. We have to balance. This is 2. See, now go back to the above data. In above data, this is equation 1, this is equation 2, this is equation 3, right? See, carbon is there. This is carbon information. It is there, carbon information. Next to hydrogen information, it's there. But here according to the given question, it is 2 moles of hydrogen. That means we have to multiply with the 2 this equation. We have to multiply with this 2. And next one, see. Here combustion, left hand side your methane is there, but here formation, right hand side is there. We have to convert the sign. Okay, now I am writing the trick here, students. Listen how to do this one. So Y, you can take it as Y. Carbon is same, no? Y you can take it. Y plus next, what is information, required information? 2H2. H2 what we have taken? Z, right? So 2 into Z, we have to multiply with the 2. Minus, why we are taking minus? Why we are taking, this is a product side. Our required one methane gas is product side. But given question in the form of reactant side, it is a combustion, it means it is in reactant side, then that's why we are subtracting this one, then minus x, then substitute this one, students, what you will get? So minus 393.5 plus 2 into minus 285.8 minus of, what is this? Minus 890.3, then you will get answer. If you simplify this one, you will get answer. What is the answer, students, here? Let me write here answer. Solution, further continuation I am writing here. So finally you will get, after multiplication, this is minus 393.5 minus 571.6, if you multiply with the 2, plus minus into minus plus, no, then this is plus 890.3. Now after simplification, this value you will get minus 74.8 kilojoules per mole. This is your answer. Okay, now go back to the question. See what is the options they had given. Minus 74.8, minus 2 minus values they will give, 2 plus values they will give. Here sign conversion plays very important role in thermodynamics, students. See, same answer, 2 different signs is there. So what is the final answer finally? Option 1, your answer. See, this is the way you can follow, easily you can get the question. In NCERT textbook also, benzene related numerical is there. Everyone try after seeing this one. I had given down one more numerical. Just we go through the one more numerical, try to do this one. Yes. What is the question? Calculate the the standard enthalpy of formation of methyl alcohol from the following data. See, methyl alcohol formation they are asking, but here see methyl alcohol combustion they had given. This is combustion. Again CO2 plus water, this value they had given. So let it be, take it as X. This is, let it be, take it as X. Okay. Next one. What is the next information? Carbon plus oxygen. What is the CO2? Yes, this is given. What is this? We'll take it as, Y. Take it as Y. This is what? Take it as Z. Right? Now what they are asking, formation of from the following, what they are asking here? Go back to the question. Enthalpy of formation of methyl alcohol. Formation. Methyl alcohol means CH3OH. It is in liquid state. See how easily we can write this one. CH3OH. CH3OH. Okay. What is the required one? Carbon need. Next hydrogen. Hydrogen, what is the standard form? H2. What is the next one? Oxygen is there. Oxygen standard form is O2. That's all. Now balance this reaction. This is graphite, no? Yes, graphite form. Now can you balance this one? Try to balance this one. Carbon, carbon. Hydrogens totally 4. Here 2. 2 2s are 4. Next oxygens, how many here? How many here? Oxygens 1. But here half. That's all. This is our required one. Here delta H they are asking. Now go back to this one. This is Y, this is X, this is Z, right? So here carbon, carbon, only one is there. Directly you can take it as Y plus 2 into Z. 2 into Z. Why I am taking 2 into Z? Here 1 mole of hydrogen, but here 2 moles of hydrogen. That's why 2Z. Next, we have to add or subtract. Check it. See, same like before question. Methyl alcohol, left hand side. Combustion means left hand side it is there, but formation time it is right hand side. So definitely we have to convert the sign. Negative, subtract. We have to subtract this one. Always adding means both the sides. If required one and given one both same side means adding, and opposite side means just subtraction. Easy trick. That's all. That's all. Now you can try this one. Values you can substitute. What are the values they had given? What are the values they had given? Yes, minus 393 point minus 393 plus 2 into minus of 286 minus of X. Right? Is it 286? Yes, 286. This is minus of 726. That's all. Now you will get answer. Simplify, we will get answer. Try to simplify this one, guys. Minus 393 minus into plus minus 2 into 286. 2 into 286. Try to do this one. Minus 286, minus of minus 726. What is the answer? This is 572 minus into minus plus 726. Now minus of minus into minus plus 393 plus 572. How much? This is what? 5 and 9 plus 7. 16. This is 9. Yes, 965. Plus 726. Now minus into plus minus. So 965 minus 965 minus 726. What is the answer, students? We will get 239. Yes, 239. This is 239. Is it minus symbol or plus symbol? Bigger value we have to take it, no? Minus 239 kilojoule per mole. See, like that very easily we can solve the questions in thermochemistry. Hope everybody liked this video. After seeing this one, Try to solve the question in NCERT textbook benzene question. Thank you students. Thanks for watching.